Most people think building an AI assistant requires code. The data says the harder part is choosing what the assistant should do today, where the signal comes from, and how you stop it from making quiet mistakes that look correct in 9 out of 10 cases until one costly exception appears. Here is what the headline missed. You can assemble a useful assistant with forms, connectors, document stores, and hosted models. But usefulness appears only when the task is narrow enough to measure and review, like classifying invoices or drafting replies, not vaguely, helping with everything across the company. The signal in this week's data is that platforms are making agents easier to launch, while independent builders are making them cheaper to run. That opens a real path for non-coders, but only with clear boundaries, success metrics, and fallback rules when confidence drops below, say, 85%. If you get this right, your assistant saves time on repetitive work. If you get it wrong, it creates polished output that hides errors, rewrites source material, and adds another system your team quietly stops trusting after 3 or 4 visible misses during normal weekly work. An AI assistant is just 4 parts: a model, a set of tools, some memory, and rules for when humans review the result before any irreversible action, payment, database update, or published document leaves the draft stage. The model is the language engine. In no-code tools, this is the easiest layer because someone else hosts it. You pick capability, context window, speed, and price, then connect it to a specific task, often trading lower cost for slower output or weaker reasoning on edge cases. Tools are what make an assistant useful. Search your files, query a CRM, draft an email, create a ticket, update a spreadsheet. Without tools, you mostly have a chat box with better manners, which sound impressive until someone asks it to actually move work forward. Memory sounds advanced, but in practice it often means approved documents, saved preferences, and recent conversation state. For most teams, retrieval from trusted files matters more than personality persistence, because policy answers from last quarter's handbook beat a chatbot that remembers your coffee order. Guardrails decide what the assistant can access, what format it must return, and when a human must approve. That is less glamorous than prompting, but it is usually where reliability starts, especially when outputs must include citations, confidence scores, or mandatory approval checkbox. If you remember 4 things, remember these: narrow task, trusted data, explicit tool access, and review before action. Most failed assistants miss one of those and then blame the model, even though the real failure is often workflow design, permissions, or bad source material. Recent updates around the agent's SDK point in a clear direction. Hosted tools are becoming more structured, with better orchestration for actions, memory patterns, and production deployment. That lowers friction for non-coders using wrappers built on top, and it suggests the stack is maturing from demo glue toward repeatable operations. The enterprise message is straightforward. Agentic workflows are moving from demos into managed environments. That matters because many no-code products simply package the same infrastructure with friendlier controls, audit logs, permission layers, procurement terms, and enough governance to pass an internal security review. If you're not coding, you're usually buying convenience. The question is whether the convenience saves enough time to justify the recurring cost, and whether you can export your workflow later if prices rise 30% or a vendor changes terms. Hosted tools win on speed to launch. Local tools win on control and sometimes cost. The trade-off is setup effort, hardware limits, and whether your task can tolerate weaker models or slower responses, especially when a 5-second delay is fine, but a 30-second delay breaks the workflow. A Hacker News project this week showed a lightweight way to make agents coordinate without paying for API usage at every turn. The broader point is not the exact tool. It is that orchestration can be cheaper than you assume, particularly for bounded tasks like routing, planning, or simple code review. Cost reduction helps only if the task is structured. If your assistant needs nuanced writing, broad research, or long context across many files, the cheap setup may save money while quietly losing quality, which is fine for tags or summaries but dangerous for contracts or compliance. Community discussions around running coding models on a 32-gigabyte Mac tell a familiar story. Yes, useful work is possible. No, it is not a free substitute for larger hosted systems across every task, especially if you need long context, faster throughput, or stronger benchmarked reasoning. The hidden price is not only subscription spend. It is latency, setup time, model tuning, prompt maintenance, and the hours you spend deciding whether a weak answer is user error or system error, which is why a cheap pilot can still become an expensive operating habit. For most non-coders, the best first assistant is not autonomous. It is supervised. It drafts, retrieves, summarizes, classifies, or prepares actions that you approve. That gives you speed without pretending reliability is solved, and it creates review data you can actually learn from later. A strong no-code assistant use case is document question answering. Upload approved material, restrict retrieval to those files, require cited answers, and block direct rewriting of the originals unless someone reviews the changes. That setup is measurable. Citation accuracy, answer coverage, and time saved per query. Another good fit is inbox triage. Let the assistant classify messages, extract intent, suggest replies, and route work to the right place. Humans keep final send authority until accuracy is boringly consistent, say above 95% for several weeks instead of one impressive afternoon demo. Meeting and research summarization also works well, especially when the output format is fixed. Think action items, risks, owners, and deadlines. Not freeform prose that feels polished while dropping the important caveat, dissenting comment, or unresolved dependency buried halfway through the transcript. Now, the key warning. A recent paper argues that delegating document work to LLMs can corrupt the documents themselves. Not always dramatically, often subtly, through omissions, phrasing drift, and source contamination over repeated edits. The kind of damage that looks harmless until policy, legal, or research details no longer match reality. The model optimizes for plausible continuation, not custodianship of your canonical record. If you let it repeatedly rewrite source files, each pass can move the text a little farther from what the original author meant, like a photocopy of photocopy, where small distortions accumulate into policy drift. The fix is procedural, not magical. Separate source from draft. Require citations. Keep version history. Limit write access. Use templates. Review diffs, not just final output. In practice, that means named owners, rollback points, and clear rules for what the model may never overwrite. A good no-code assistant follows a simple loop. Retrieve trusted context, perform one bounded transformation, return structured output, and ask for confirmation before changing systems of record. If you can diagram that loop on one page, you can usually govern it. You can build them. The better question is whether you should. In most business settings, autonomy is valuable only after you have enough logs, enough review data, and enough confidence to know where the assistant fails. Because unsupervised speed just scales mistakes faster than supervision catches them. Social posts often compress a messy workflow into a clean success story. That does not make them false. It does mean the setup time, supervision, and domain expertise are often hidden off camera, along with retries, prompt revisions, and a manual cleanup that made the final clip look effortless. A viral post about using an AI model to guide home genome sequencing is interesting for one reason. It shows how quickly confidence can outrun safeguards when a capable assistant enters a high-risk domain, where a plausible suggestion is not the same thing as medically or scientifically safe guidance. The same lesson appears in robotaxi expansion news. Shipping an impressive capability into real streets is not the same as showing a polished prototype. Your assistant also lives in the mess of real operations, where exceptions, bad inputs, and partial data appear every single day. So, if you want to build without coding, you have three realistic paths: hosted no-code builders, workflow tools with model connectors, or local setups for narrow private tasks. Pick based on risk, not fashion, because the cheapest demo and the safest production choice are often different. Use hosted no-code tools when speed matters, collaboration matters, and your data can live in a managed environment with acceptable compliance terms. They are often the right answer for teams of 5 to 50 that need results this quarter, not infrastructure experiments. Use workflow automation tools when your assistant mainly moves information between systems. In that case, the model is one step in a larger pipeline, not the product itself, and reliability depends as much on triggers, schemas, and retries as model quality. Use local models when privacy is critical, the workflow is stable, and you can tolerate setup work. They are best for constrained tasks, not as a universal answer to every assistant problem, especially if your team lacks time for maintenance, updates, and evaluation. If you want one practical starting project, build an assistant that answers questions from your approved documents and drafts a structured summary with citations. Small scope, clear evaluation, low organizational drama, and an obvious rollback plan if the answers drift or trust drops. Signal, not noise. See you next week, and remember, build for evidence.